Morning students. In the previous video we have learnt about the characteristics of different states of matter, that is solid, liquid and gas. Today let's learn about change of state of matter. There are three states of matter: solid, liquid and gas. Can a solid be converted to liquid or a liquid be converted to gas? Of course we can. How does this change of state take place? Due to the effect of change of temperature or change of pressure. In this video, let's discuss about the effect of change of temperature while the pressure remains constant in detail. Matter in solid state becomes liquid on heating. On further heating, that is increase in temperature, the liquid becomes a gas. Similarly, on cooling the gas, the particles condense to form liquid. On further cooling, that is reducing the temperature, the liquid becomes solid. Let's start with the first process, that is conversion of solid to liquid in detail. As shown in the picture to your left, the ice is solid, melts with increase in temperature to form liquid, that is water. The particles in the ice, when it is solid, are tightly packed and the force of attraction between the particles are high. On heating, the kinetic energy of the particles increases and starts vibrating with greater speed. The particles leave their fixed position and starts moving freely. Energy from the heat supply overcomes the force of attraction between the particles. At a specific temperature, the particles of the solid substance melts, moves further away from each other to become a liquid. Definition of melting point. The temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of ice is 0 degrees Celsius or 273.16 Kelvin. The process of melting, that is change of solid to liquid state, is known as fusion. The melting point of solid is an indication of the strength of the force of attraction between its particles. As shown in the picture, the water, which is a liquid, vaporizes with increase in temperature to form gas. The particles in the water, when it is liquid, are loosely packed and the force of attraction between the particles are higher than that of its gaseous state. On heating, the particles of the liquid overcomes the force of attraction between them to move even faster and more freely. At a specific temperature, the particles of the liquid vaporizes to become gas. Definition of boiling point. The temperature at which the liquid starts boiling at the atmospheric pressure is known as its boiling point. The boiling point of water is 100 degrees Celsius or 373 Kelvin. The process of boiling is a bulk phenomenon. Particles from the bulk of the liquid gains enough energy to change into vapor state. As shown in the picture, the water vapor in the air, which is in gaseous state, condenses with the decrease in temperature to form water, which is in liquid state. The particles in the air, when it is in gaseous state, are freely moving and the force of attraction between the particles are very less. On cooling, the particles of the air condenses, that is the particles in air move closer to each other to form liquid. On cooling, the particles of the gas condenses to become liquid. The process of converting gas to liquid on cooling is known as condensation. As shown in the picture, the water droplet, which is in liquid form, freezes with decrease in temperature to form ice, which is a solid. The particles in the water, when it is in liquid state, are freely moving and the force of attraction between the particles are less. On cooling, the particles of the water solidifies, that is, the particles in water move closer to each other to form a solid substance. On cooling, the particles of the water solidifies to become solid. The process of converting liquid to solid on cooling is known as solidification. Experiment to determine the melting point of ice. Take some ice cubes in a beaker along with a stirrer. Place it over a wire gauze on a tripod stand. Insert a thermometer and hang it over the beaker with the help of a clamp stand so that the bulb of the thermometer remains in the middle of the ice cubes. Now, heat the beaker with ice cubes at a moderate temperature with a Bunsen burner and stir continuously to maintain a uniform temperature throughout. When the ice starts melting, note the temperature on the thermometer as T1. Continue heating the beaker. Note the temperature T2 when the ice is completely melted into water. The average of the two temperatures you have noted as T1 and T2 is a melting point of ice, that is 0 degrees Celsius. Experiment to determine the boiling point of water. Take 25 ml of distilled water in a boiling tube and clamp it to a stand. Take some pumice stones in a spatula and put them in the distilled water to avoid bumping of water while boiling. Close it with a double bore cork. Insert a thermometer in one bore of the cork and make sure the bulb of the thermometer rests 3 to 5 cm above the water in the boiling tube. Insert one end of the delivery tube in the other bore of the cork and place the other end in a beaker. Heat the boiling tube with the Bunsen burner. Note the temperature when the water starts boiling as T1. On boiling, the water is converted into steam and passes through the delivery tube, is condensed and gets collected in the beaker. Continue to heat the water until the temperature becomes constant and the water continues to boil. Note the constant temperature T2. The average of the temperature T1 and T2 gives the boiling point of water. The boiling point of water is 100 degrees Celsius.